Welcome to Sine and Cosine Ratios. I'm Mr. Pi, the math guy, and I'm your host today, and this is a geometry lesson. Up here in the red, what we do have is a right triangle. C is the right angle, and what we're going to be talking about here is in terms of angle A, the sine of angle A is equal to the length of the opposite leg over the length of the hypotenuse. And if you watched my previous lesson on tangent, hopefully you understood from that lesson that we can have the sine of A and the sine of B in these cases, which are going to be two different angles we're going to see. Up here, or down here in the blue, C again is our right angle, and the cosine of angle A is equal to the length of the adjacent leg over the length of the hypotenuse. We're going to study these a little bit more through example. Welcome to sine and cosine ratios. Here we have the sine of angle A, and that's equal to the length of the leg opposite of angle A over the hypotenuse. In this case here, if we were to write that down and simplify that a little bit, the sine of angle A is equal to, now the length of the leg opposite angle A would be BC, so that would be given as BC over AB, the hypotenuse. And here the cosine of angle A is the length of the adjacent leg adjacent to angle A over the hypotenuse. So the cosine of angle A in this case is going to be AC over AB. Using the lengths of legs, a very geometric way to represent the idea of sine and cosine for this specific right triangle. Example 1, we are asked to use the triangle to find the sine of angle T, the cosine of angle T, the sine of angle G, and the cosine of angle G. So what we're going to end up with here is 4 different answers. So we're going to start off with the, just as in order as they are, the sine of angle T. Now, this sine is going to be the opposite over the hypotenuse. So the sine of angle T is going to be GR over TG. Putting those numbers in, that would be 12 over 20. Well, 12 over 20 does in fact reduce. 12 over 20 reduces by a factor of 4, which gives 3/5. The cosine of angle T is going to be the side adjacent, TR, over the hypotenuse, TG. And that's going to be equal to 16 over 20. And that again reduces by a factor of 4 to give 4 over 5. Now, moving to the other angle, angle G, the sine of angle G is going to be equal to RT over TG. Which is going to be 16 over 20, which reduces by a factor of 4 to 4/5. And finally, we're going to have the cosine of angle G, which is the side adjacent, GR, over the hypotenuse, TG, and that's equal to 12 over 20, which reduces to 3/5. So here, just really understanding the idea of ratios and seeing that the sine of one angle is equal to the cosine of the other angle. It's kind of neat that they are inverses like that. In example 2, we're going to do some problem solving that involves the sine or the cosine. So we're going to take a look at it, and we're going to take a look at it using RISE, where we're going to read, illustrate, solve, and explain our problem. And again, you'll see here, if you've been watching my videos in series, I've been using RISE for quite a few lessons, and we use quadrants to organize our work. In the read portion, when we read the problem, we want to write down important information, including the question. So let's go ahead and read. A 20-foot wire supporting a flagpole forms a 35-degree angle with a flagpole. To the nearest foot, how high is the flagpole? So, what do we know? We know we have a 20-foot wire and that wire forms a 35-degree angle with the flagpole. So 35-degree angle between flagpole and wire. And the question is, how high is the flagpole? Okay, over here in the Illustrate, I already got a diagram started for us. Here we have a flagpole. We can see the flag. What we know is that this wire is 20 feet long. We know this angle between the wire and the flagpole is 35 degrees. What we want to figure out is how tall the flagpole is. So what we have here is an adjacent hypotenuse relationship. This is the 90-degree angle. This is the side adjacent to the angle in question, 35 degrees. This is the hypotenuse. So down here in our solve, we're going to use our cosine, which tells us the cosine of any angle x is equal to the length of the side adjacent over the length of the side, which is the hypotenuse. So we'll substitute in what we know. We know the cosine of 35, and we know 35, we know the value of the angle, and we know the length of the hypotenuse. And the length of the hypotenuse is 20. Well, this is similar to an example I did in the tangent lesson where we knew the angle and the denominator. So what we have to do to solve this is we have to multiply both sides by 20. When we multiply both sides by 20, what that does is get the variable isolated. The 20s on this side cancel out, leaving us with x solved for now. And what we have to do is calculate this on a calculator. 20 times the cosine of 35 degrees. Well, when you run that through your calculator, x ends up being approximately equal to 16.3. Now, the reason I stopped at the tens place is because it asked for to the nearest foot. So to the nearest foot's going to be 16 feet. So when I go into my explain problem, and what I'm going to write in my explain problem be something you might want to write on a standardized test or any test for that matter. After making my diagram, I realized it was a cosine relationship. And found the length and found the height of the flagpole to be about 16 feet. So there's using cosine to solve a problem and using rise to show your work, to read, illustrate, solve, and explain your work. Example 3. We're told that a right triangle has a leg of 1.5 units long and a hypotenuse 4.0 units long. Find the measures of its acute angles to the nearest degree. There's really two ways to do this. We saw that in a previous example. So let's start by labeling this here. We'll just label the length of RS as 1.5 and the hypotenuse RT is 4.0. So if we're talking about angle T, we're talking about the side opposite over the hypotenuse. So that would be the sine of angle T. And that's equal to 1.5 over 4.0. Now to find the measure of angle T, we use the inverse of the sine, which we just write as sine to the negative 1 power, and that'd be of 1.5 over 4.0. Now at this point, that would be ridiculous not to use your calculator. plugging this into your calculator, if you have any kind of scientific 2 graphing calculator, it's probably pretty standard to have that inverse sine function right probably in the second function tools. So when you do that, that ends up being approximately 22 degrees. Now, one way of doing this, and I think the quick way, is once we know that angle T is 22 degrees, we know R is its complement. So the measure of angle R is equal to 90 minus 22, and 90 take away 22 is equal to 68 degrees. Another way to do that would be to find the cosine of angle R. And the cosine of angle R is going to be equal to 1.5 over 4.0. And if you use that inverse function again, find out that the measure of angle R is in fact, when you round it, 68 degrees. So you could have done it a real quick way, or showed that you understood the sine and the cosine. It really doesn't matter as long as you understand how to find the measures of these angles using either the sine or the cosine function.